traversing a linked list is simply a matter of going node by node and keeping track of where we currently are and going all the way to the end. Now, typically we have one pointer that points to the entire linked list. Like right here, we've got this pointer head pointing to the head of the linked list. And we did that in our code here with creating that pointer called head. And later we assigned it to the beginning of the list or to a node that we had inserted. Now to traverse, we need a second pointer, and that's one that we'll call current. So I'm going to create a pointer here called current. And with this line of code right here, we're going to assign current to head. So wherever head is pointing, current is also going to point to it. So now we're going to have current point to the first node. Note that we're not going to change where head points. That's going to stay stable and always pointing to that head first element of the linked list. So next, we enter a while loop, and we're just going to use this while loop to go all the way across. We start with while current, and what while current means is while the pointer is still pointing to a valid node. Because what will happen is as we advance this pointer, eventually it's going to point to outside of the linked list. It's going to actually point to the null pointer. And if that is the case, well, we know that we've traversed all the way past it. Now, while current is the equivalent of this code here. So while current does not equal the null pointer is the exact same code as just while current. And this is saying as long as current is pointing to a valid node, what will happen is current is eventually going to come over here. And when we finally advance that pointer, it's going to start pointing to the null pointer, and then while current will fail. So now that current is pointing to a valid node here, to this node here, number one, we can withdraw or reference the data that's in that node, whatever we've created. So here I just have value as a dummy placeholder. We can use the arrow operator to reference that value. So we can count it. We can use it to sum up the values in the linked list, for example. Maybe we have to create an average, etc. You get the idea there. Any object that you want to put in there, we can now reference it with current arrow. And again, we've got to use the arrow operator, not the dot operator, because we are dealing with dynamic memory, dynamic pointers, memory allocated on the fly, and all of those are the use cases for the arrow operator. Now, once we've retrieved that piece of data, what we have to do is just now advance that pointer current to the next node. Now, current right now, we can say that current arrow value is referencing this data right here. We can also say that current arrow next is actually this pointer right here, and it's pointing already to the next node. It was created that way. So we can just advance the pointer by executing this code here, current equals current arrow next, and that is going to get rid of this pointer current, and wherever current next is currently pointing, which is this second node, we're now going to point to that. Then we repeat this process again. Current will eventually point to here now, and then we'll repeat the process again. And now let's say current is pointing to here now. We advance it again. Current then is going to point to the null pointer, and we know that we have traversed the complete linked list. And here's what the code implementation looks like. Here is where we are creating that second pointer that we need. Remember, the head is always going to point to the head. We never want to remove that reference to it, or else we'll have a memory leak. A memory leak is where we've allocated memory, but we have somehow lost the ability to reference it. Or perhaps we had a pointer and we pointed the pointer somewhere else, and now we have no way of getting back to that memory. So head will generally always point to that, and we do need that second pointer that's going to traverse the linked list and point to every node as we go on. So that is just going to be called current. And then here's that while loop, while current. And again, remember that current is the same thing as while current is not equal to the null pointer. This line right here, line 39, gives us the reference. So we can go and extract current arrow value and have access to that piece of data. But then incrementing our pointer to that next element is just current equals current arrow next. When current is currently pointing at a node, the value current arrow next is actually pointing to the next node. And we can just change that pointer to point to that now.